Yes. You say you are the Einstein. I say you are the Gabriela. All right, let me call you back. Let me speak to you later. All right, take care. All right. Hello, everyone. This is Science Professor Obene. This is Science Professor Obene. Welcome to the channel. If you haven't subscribed, you need to hit the subscribe button now. Subscribe, subscribe, subscribe. All right, so today we are going to look at how energy flows through ecosystem, the flow of energy through ecosystem. In almost every ecosystem, energy flows through the ecosystem in only one direction, usually from the sun to producers, to herbivores, to carnivores, and finally to decomposers. What we should remember is that the arrows, they show or they represent the flow of energy. The arrows show or represent the flow of energy. Okay, so this means that the energy is going to the plants. The energy is going from the plants to the herbivore. The energy is going from the herbivore to the carnivore. And finally, when all these organisms, when they die, the energy will go to the decomposers. They will break down all the dead plants and animals. Okay, so energy flows from the sun to plants to herbivores to carnivores and finally to decomposers. So now let's look at food chain. When we talk about food chain simply means food chain shows the relationship among organisms. It shows the feeding relationship, one single feeding relationship. Okay, it shows a path of energy from one living thing to the next. So this means that the energy is going from the grass to the cricket. The energy is going from the cricket to the frog. That means that the frog eats the cricket. That's what it means. The arrows, we should remember that the arrows, they represent the flow of energy. All right. So we should also point out that some energy is released into the environment as heat. At each link in the food chain, some energy is released into the environment as heat. Okay, so not all the energy from the grass gets to the cricket because some of the energy is converted to heat. Not all the energy after the frog consuming the cricket, not all the energy will get to the frog because some of the energy will be converted as heat. Okay, so let's look at this question. Let's look at this. You know, the toxic chemicals such as mercury, they accumulate in the tissues of animals in a food chain. All right. So if this organism, if the plants, if they contain mercury, all right, it will get in the food chain. It will get into the cricket. And if the frog consumes the cricket, the energy will be passed on to the frog. And one thing that we should point out is that the energy they accumulate. So if the frog is consuming the cricket, that means the energy will accumulate into the frog. So the concentration of these chemicals is higher in predator species than in the prey organisms. So that means that the concentration in the cricket, okay, if the frog consumes the cricket, the concentration of the mercury will be higher in the frog compared to the cricket. Okay, because the concentration of the chemical they accumulate in the predator organisms. All right, remember the arrows, they represent the flow of energy. The arrows represent the flow of energy. All right, so let's look at this food web. Food web is simply many interconnected food chains. So here it says identify two herbivores that compete for food in this food web. So in this food web, two herbivores that compete for food, they include mice and also cricket. So mice and cricket, they compete for food, which is the same food, grass. State the role of decomposers in the food web. The role of decomposers is that they break down dead plants and animals. They break down dead plants and animals. They return or recycle nutrients back into the environment. All right, the next question that we should be able to answer easily is that it says, even though both hawks and owls, we see hawks here, we see owls here. Even though both hawks and owls have two sources of food, explain why hawks will be least likely to survive if a disease wipe out the mice. So if a disease wipe out the mice, explain why hawks will be least likely to survive. So the reason is If you look at the food web here, it shows that hawks, they feed on snakes and they also feed on mice. But owls, they feed on mice. They also have alternative source of food as frog. So this is the reason why owls will be the most likely to survive compared to hawks, because owls, they have second source of food, which is a frog, and does not depend on mice. So if a disease wipes out the mice, the owls, they will have alternative source of food. All right. So here we are looking at identifying food chains and food web. Okay. So whenever you see a food chain or a food web, remember a food web is many interconnected food chains. Many interconnected food chains. Okay. The arrows always, they represent the flow of energy. Energy flow from the sun to producers, to herbivores, from herbivores to carnivores, and finally to decomposers. Okay, so when we look at this food web, this is an ocean food web. In this food web, we see many interconnected food chains. Okay, so let's look at this question that goes with this food web. All right, so the question reads, if the fish population decreases, what is the most direct effect this will have on the aquatic ecosystem? So if the fish population decreases, what will be the most direct effect? So the most direct effect is that you need to look at what the fish consumes, what the fish eats. All right. So the fish, they eat zooplankton. So if the population of fish decreases, then the zooplankton population will increase in size, because there will be no fish, eating the zooplankton. So that will be the most direct effect if the population of fish decreases. If the population of fish decreases, the population of zooplankton will increase in size. Okay. Energy pyramid. Energy pyramid shows the amount of energy and the number of organisms at each trophic level. Energy pyramid, it shows the amount of energy and also the number of organisms at each trophic level. All right. So here we see producers at the bottom here. We see the next levels of consumers. All right. So if you look at this energy pyramid diagram, you see that as you move from producers to the next levels of consumers, all right, the amount of energy being transferred decreases. Only 10%, only about 10% of energy gets transferred from producers to the next levels of consumers. So at each level, only about 10% is being transferred. And this means that some of the energy is converted to heat. All right. So in this energy pyramid, we should also know that the greatest amount of stored energy is found at the producer level. They have the greatest amount of stored energy. And as you move up, the amount of energy decreases because some of the energy is converted to heat. That's why the pyramid becomes smaller. Some of the energy is converted to heat. So that's why the amount of energy decreases from producers to consumer organisms. Some energy is converted to heat. Now let's look at population graph. All right, let's look at population graph. So population graph at point B. Point A means the population is going up, population is increasing. All right. B is the carrying capacity. B is the carrying capacity. Carrying capacity means the maximum number of individuals that the population or that the environment can support. That's a carrying capacity. The maximum number of individuals that the environment can support. Okay? And when the population goes above the carrying capacity, what the environment can support, we call it overpopulation. That means the population has gone above the carrying capacity, what the environment can support. For example, in a classroom settings where you have 32 seats, the carrying capacity of the classroom is for 32 students. Okay, so beyond 32 students, then you are going into overpopulation. Point D means the population is decreasing, population is going down. All right, so that's a carrying capacity. And the factors that can cause population to increase, they include more food, no predation, good weather, no disease, and no competition. The opposite is what will cause populations to decrease, and they include no food, predation, bad weather, diseases, and competition. Okay? So let's move on. Now we are looking at limiting factors. When we talk about limiting factors, they are the factors that control the population size. Limiting factors, they control the population size. So the factors here control the population size. Non-renewable resources, they are finite resources in the environment. Non-renewable resources, they are finite. They will run out. They have an end. They have limits. They are being used faster than they can be replenished. Okay, so a finite resources in the environment. A finite resource is a non-renewable resource in the environment that cannot be replaced or replenished as quickly as they are used or depleted over time. So non-renewable example, coal, natural gas, and petroleum. All these materials, they are used faster than they can be replenished or replaced. That's why they are called non-renewable sources of energy. So non-renewable sources is equal to finite resource. Finite resources, they are non-renewable resources. Limiting factors are factors that control the population size. So a finite resource in the environment that keeps a population from steadily increasing is a limiting factor. So a finite resource that keeps the population from steadily increasing is a limiting factor. Examples of non-renewable resources or finite resources, they include earth mineral, metal ores, fossil fuel. Fossil fuel, they are coal, petroleum, natural gas, and groundwater in certain aquifers. Non-renewable resources, they are finite resources. Non-renewable resources, they are finite resources. Okay? So we should know what finite resources are. When we talk about finite resources, they are non-renewable resources in the environment. They cannot be replaced or replenished as quickly as they are being depleted. Examples of finite resources or non-renewable resources, they include earth's mineral, metal ores, fossil fuel. These products, they are used faster than they are being replaced. They are used faster than they can be replenished. Fossil fuel, for example, can take millions of years for it to be formed. So as we use them faster than the way they are being replaced, we call them finite resources. We call them non-renewable resources. They are finite. They have an end. Okay? So now looking at the population graph again, at point A, the population is increasing. We should know the factors that can cause population to increase. Factors that can cause population to increase, they include availability of food, good weather, no predation, when there are no lions, to kill and eat the zebra. All right, the zebra population will go up. Okay, when there is good weather, the zebra population will be able to thrive, survive, and reproduce. So their population will go up. Okay, and when we go to B, B is a carrying capacity. Carrying capacity simply means the maximum number of individuals in the environment that the environment can hold. The maximum number of individuals that the environment can hold, of a particular population that the environment can hold. When you go beyond the carrying capacity, you are going in the territory of overpopulation. Overpopulation means it's beyond what the environment can support. All right, so it will come back to the carrying capacity. All right, then at point D means the population is decreasing. What causes population to decrease? They include no food. When there is greater competition, that will cause populations to decrease. When there is no food, populations will decrease. When the weather is not good, suitable enough for the organism, the populations will decrease.